Swayam Prabha. Digital India. Educated India.
Welcome back. In this lecture, we will start, in this module 11, we will start Internet of Things, and within this lecture, which is lecture 51, we will start Introduction to IoT. So, the different concepts that we will cover in this lecture is why we get to know or we should learn about IoT. And IoT, then we will go into details about what is IoT. IoT is short form for Internet of Things, of course. And then we will talk about a little bit about the market for IoT and what kind of value IoT creates. And then we will give some examples of IoT applications. So I would rather start with some questions. For example, for all of us, most of us live in urban areas. You have seen that in many urban areas, the street lights automatically turns off in the morning, or it gets dim when the light is not that required, or it could be turned on as well during the evening, right? So who or what tells the street lights when to turn on or either when to dim, or how rather it happens? Or for example, most of us use Google Maps to navigate. That means we can we give a destination and we see that okay, what is the shortest path or the proposed route, as well as the travel time attached to it. And it not only does that, it also shows us where there is a traffic jam, or along the way we get indication of this is the travel time. It may be more than the normal one, and we can see that at certain section of the road there is a lot of congestion. So before we actually reach the congestion, we are able to see that okay, there is congestion over there. So how does that happen? So obviously Google is embedded in all our mobile phones, the Google softwares and all. And our mobile phones act as the IoT devices, which is sending data regarding, are we moving or not? And, based on that, Google can make sense of where a congestion is occurring. So that actually means that we have to have some devices which is sending information over the internet, and that information is processed. And once it is processed, it is fed to an application, which is Google Maps or Google Navigation. And we can see there is congestion, and we can take a meaningful decision which adds value. That means because I'm seeing congestion, I may change my route, or I may decide to stay back, not go in a certain direction. All the different decisions that could be taken because of that particular information. So similarly, how does a city know which parking spaces are empty? That means how can I track parking, if a parking space is filled or not? That means that how can I detect that how can I detect that space is occupied or not? Is there a camera involved? Are we taking a continuously picture and sending it and seeing when it is occupied? But it may be very costly because the camera feed takes up a lot of both bandwidth as well as to store it, you require more money, right? So, or it may be a very simple sensor which detects that area is occupied or not. So all these different things is part of IoT. So sometimes when you walk along, long buildings and you see the lights along corridors, maybe like in IIT, we have got long corridors where at evening when you walk, the lights turns on, and when you walk past it, the light also turns off. And then sometimes some buildings, they can lock, the doors get locked themselves, right? AC adjusts flow of cool air. So maybe it is based on occupancy, it is detected how many people are there in the room. Accordingly, the amount of air is being sent, or maybe along with temperature and other parameters. So what else is measured, or how do I measure occupancy? Is it via camera, or is it via CO2 sensor, where the amount of CO2 in the room is an indicator of how many people there are? So what kind of data is collected? Where does this data go? How it goes? All is part of the questions that will be answered by IoT. So similarly, a lot of people in nowadays wear watches or certain kinds of bands which can track their heart activity or their pulse and different parameters, their oxygen levels and so on. So we can and a lot of these devices are now coming so that these are fitted in people who are prone to this kind of diseases, or at people of a certain age group, and then we can monitor the data, right? And this data could be local, or it could be monitored or sent to a server. From there it could be monitored by anybody. So then there are other types of question that comes in. Yes, that will, in case something bad happens, immediately there could be intervention. At the same point of time, your data doesn't remain personal. Or should that, or in that case, should we do automatic monitoring of certain things by necessity? So can cities use this data during also heat waves, pandemics, or disasters to generate some more insight and help the citizens? So that means you are even making it more from the very private data, it becomes public. Then to do that, you have to do a lot of you have to remove the identifiers that who this data belongs to and so on. But all this system, this is part of the IoT system. So then again, if we take the cases of infrastructure, how does a city know that a transformer is going to fail? Are we measuring something with a sensor there? Or a waste bin is getting full, am I using an infrared sensor to see that at what depth the garbage has reached, or a water leakage is happening before a complaint is being launched or before actual failure happens? So that means instead of being reactive, we can be very proactive if I go use this IoT systems. So what we are seeing is cities are gradually becoming sensor rich. That means if there are more and more sensors which are getting embedded into our lives, into the infrastructure, into the way we do things. And more, and and cities are also growing very connected. These devices talk to each other, these devices talk to servers, and data driven. That means the data that is being analyzed, and that is used for some certain decisions. And so the question is, that means it is rather the question not is that will IoT be shaping our cities, or is IoT that important in cities? But now the question is whether urban professionals are ready to understand, govern, and design with IoT. That means IoT should become a part and parcel of the way we work, or rather take decisions in urban areas, and we govern it. So what is IoT? IoT is the short form for acronym for Internet of Things, and it refers to a network of physical objects embedded within urban spaces such as buildings, vehicles, infrastructure, devices, and even within people equipped with those kind of devices. And each of these devices are equipped with a unique identifier. That means it has got an identity. Why that is required? Because if you have an identifier in the internet, I can detect through internet or through IP protocols that where this device is. I can track that device, or I can that becomes like, okay, if in case of security control, access control, based on the device ID, we can allow it to access something or not. So with unique identifiers, and then also this device has got sensors that enable them to collect and exchange data over networks automatically and without direct human intervention. So that means it's an embedded device, IoT, which is connected to the network, and it gathers data using sensors and sends the data over network, and this all happens without more or less human intervention. Now, the IoT is not new actually. IoT gradually has evolved over time. So initially we were focused more on M2M, like machine-to-machine communications. So that actually refers to direct point-to-point communication between devices. And that means we have a device, it has got two parts, and these two parts communicate with each other, right? Or it could be one device communicating with another device, right? So usually within existing hardware, these were all embedded, means it's a part of a bigger hardware and so on. And they used to communicate using either cellular or wired networks. So both via cellular signals, Wi-Fi, or even Wi-Fi signals, or wired networks. And they have very little scalability or integration with other things. That means once the device is communicating with whoever it is supposed to, it is fine. We are not thinking of scaling this entire system up for other all across the city or all across the different branches of the industries and so on. So IoT actually, Internet of Things actually allows us to do that. Now because now Internet is key to this, right? That means the device is connected, not only connected, it talks over the Internet. So IoT uses IP-based Internet connectivity, right? So it is Internet protocol-based Internet connectivity. That means the device has got an IP address, and it can talk, follow the TCP protocols and can talk through the internet and communicate via the internet. And this one component is the internet connectivity part. Then comes along with middleware and cloud platforms. So IoT is not just a device which collects data or not just the sensor. Sensor is one part of IoT, but once it sends, there is a middleware. That means there is a software which decides what to do. Should I just transmit the data forward, or should I do some analysis over here? And where does it transmit to? It transmits to mostly cloud platforms. That means it is like servers where database hosted in some cloud servers, and that is being and the data is being sent there. And this middleware and this cloud platforms, either separately or together, they manage the data, support multiple protocols, and enable large-scale integration and analytics. So it is a natural extension of the SCADA or supervisory control and data acquisition system. So we have seen SCADA system across different industries like water treatment plants, where we actually can follow the processes. That means it is mostly for real-time process control. So this is a very common term used in computer science, or rather in computer-based systems, where we can monitor different activities, and not only that, there is a feedback coming, and using the feedback I can also do some changes to the the processes that are happening so that we rectify those problems. So real-time process control in that part is important. In closed industrial environments to large-scale network data-driven applications. So now from very closely organized systems or industrial closed-door systems, we are now making it more generic, more network, and more data-driven as well. So that is the change that has happened from M2M to IoT. So IoT represents a paradigm shift in endpoint intelligence and not just connectivity. So we are not just connecting things, we are also adding intelligence, we are processing data. All this has now become part of IoT. So IoT devices from basic data transmitters, that means they were collecting data and transmitting the data. That was the initial devices. Now now it is also trying to make sense of the data. That is where edge computing comes in. Sensors collect the data, and the microcontroller or the processor, whichever is used, that actually processes the data, and using the software inbuilt, which could also be some sort of AI algorithms and other things, we do analyze the data, not all devices, some devices, and then the data is processed and the meaningful information is sent to, some part of the data is sent to for cloud, or some part of the information is sent to cloud for further analytics, or rather or just for storage. So that is which has changed over the last decade. And finally, how to respond to their environment. That means in some cases what happens, the response has to be immediate. I cannot wait for the data to be sent to the server, processed, and then I will act upon it. It has to be immediate. So that means we have to do the processing within the device itself, right? So that is known as edge computing. And this, once it happens, I can immediately respond. So giving a response is also part of the IoT system. So I am both sensing as well as I am also responding to that particular sense or change in the environment. So to summarize what is IoT and the different aspects that is connected with IoT, one big aspect is of course the communication part, right? That means IoT is all about communication. That means it is sending the data over a network to a much more larger community or to a cloud server or for further use, right? So usually we go for standard protocols, of course, but within that also there are some specialized protocol applications as well, some non-standard applications as well for more private communication and all. But more or less we use standard IP protocols for communication. For example, air quality sensors sending data to a cloud dashboard. So that means whatever data is being gathered, it is being sent to a server, and then the data is processed and displayed in a cloud dashboard, or it could be directly displaying to a cloud dashboard as well. So what are the protocols that we follow? Of course, the IP protocol is the most important internet protocol. It is basically a set of rules which allows unique addresses for every device. That means it gives every device a unique ID, and using that ID I can refer to a device in a large network. So that is how the device could be identified in the first place, right? So then comes the transmission control protocol, TCP, and TCP/IP, we call it together. So transmission control protocol is how data is transmitted over the internet. So the data needs to be, packaged, then those packages are sent over the net. It is received by somebody. It, then combines the packages or interprets it. So all these protocols for doing that is the TCP/IP protocol. So obviously, IoT devices follow the TCP/IP protocol. So it ensures that transmission between devices and the servers happens smoothly. So similarly, HTTPS is also another set of protocols. So these are web protocols which allows sending of data to the servers of the dashboard. So that means one is to establish the transmission, the way the transmission should happen, and the other is what to carry, how to carry. So that part is what to carry is like, those things are taken care of by the HTTP protocols. Then there is a very special protocol, MQTT, which we have discussed earlier, sometime maybe in earlier lecture, which is the message queuing telemetry transport. Now, what it means is it is a similar protocol to HTTP, but it's a little bit different. It follows a publish-subscribe protocol. Now, the reason is different. Now, when that means that particular device that is collecting the data, that publishes the data, there is a middleman called broker, that is via broker. So it is basically a server, right? That server receives that particular information, and the devices which subscribe to this particular broker will get those particular data immediately. So it doesn't ensures one-to-one communication. It is actually we are publishing the data first, and then it is being read by others. So it actually ensures much more faster communication because there is no direct handshaking involved with two devices and communication between two devices and all these things. So usually this lightweight protocol is used for low power devices. Then there is the COAP protocol, Constraint Application or COAP protocol, Constraint Application Protocol. It is an alternative to the HTTP protocol for constrained devices such as battery powered sensors, suppose in water pipelines, right? So that means the battery size is very small and all, so it has got little power. So that is where we will use protocols which will not consume that much energy. So that is where Constrained Application Protocol comes in. Then there are of course WebSockets, which we have discussed earlier. Now it actually enables it follows the TCP protocol, but it enables continuous real-time two-way communication, right? So it's a two-way communication that is ensured between these devices. Now, beyond the communication part, of course, there is the middleware and the cloud layers, which acts as a bridge between the field devices and the urban applications. That means we have the sensors, and then we have the actual urban applications, which shows us the data and all. And these bridge devices actually help us to manage the data. It helps us to store the data. It helps us to process the data, and also gives access to the relevant device or the relevant people. So this middle layer or the cloud layer, these are middle layer is usually the firmware or the set of code that is there in the device itself, that is within that microcontroller. The code has to be put in, uploaded, and the microcontroller, when it receives the input, it will act in a certain way, right? So that logic that is written there, that part is the middleware. Similarly, another part of the middleware could be also, or another part of the application or this logic could be in the cloud itself, right? So that means some of the data is directly transmitted, that could be also processed in the cloud. So both these processing layers, that is the middleware layer and the cloud layer, this actually works on the data that is being sensed, and then it gives a sort of actions which needs to be implemented via some actuator or via just displaying the information in form of dashboards. So like in city dashboards, monitoring the status and energy use of thousands of street lights in real time is a perfect example of this. So then internet connectivity is of course central. This allows continuous real-time monitoring and control. That is, because there is continuous internet, we can live track the buses across the entire city. And then IoT should support heterogeneous protocol and devices, right? There may be many devices connected to a server, some following HTTP, some following MQTT. So IoT should support all these things happening together, right? It shouldn't suppose only few things. Then different kind of sensors could be also fitted, those should be also like CCTV cameras, parking sensors, and eventually this has to be displayed in mobile apps. So all this has to work together seamlessly, and that has to be supported by IoT systems. And finally, it has to be a highly scalable and integrable ecosystem. That means new devices can be added very easily, and it should be done in such a way so that we don't have to disrupt the entire network or the service and then stop and install something. But in most cases, it's just plug and play, right? So, like for example, I install a smart waste system in one ward, and then I make it for the full city without changing much. So we keep on adding, and we can get a long time. May say over a period of 2 years, we gradually make all the wards smarter, right? Now, now that we know something about what is IoT, now looking into the market of IoT, or rather the value it creates, we see that it is increasing at a rapid pace, and approximately around 18.5 billion devices were recorded to be connected globally in 2024, and right now we expect around 20 billion now, which includes both consumer level deployments and industrial level deployments. And then it is expected that by 2030 around 29 to 40 billion devices will be there. And why? Because now there is a lot of advancement in the this low powered networks, low powered devices, communication modes which use less power, cloud platforms, AI enabled edge computing. So all these things are very, very new, and people are working on this to actually add value. Now, of course, we will talk about value creation after this. And then the estimated IoT spending was around $805 billion in 2023, and it's likely to become 1 trillion by 2026. So it shows that there is a lot of investment happening across, and it is not only restricted to a few industries or a few sectors. It is more or less all across different industries and different sectors. So if we just say that IoT is just the technology or the technology stack, then it's a wrong thing. Why? Because the business model, the way we use IoT to take decisions, that means governance, all this is part of IoT systems, right? So, and that means that we actually are going for this kind of systems because it is adding value, right? So that means it has to allow value, then only I can justify installation of this kind of devices, because there is maintenance, then there is also repair, replacement. So if it doesn't create any value, what's the point of installing it in the first place? So from an economic value perspective, that means how much value IoT creates. While you see that investment required is around 1 trillion, we can say that it is expected to generate around 5.5 trillion to 12.6 trillion in annual global value by 2030. So you can see that how many times it is giving us returns, right? So that means it is creating value. That's why people are adding more of these systems on ground. So most of the contribution is from manufacturing side. In industries and all, we are seeing IoT systems being included. And then we are also seeing a lot of these installations in healthcare, then in utilities, and in urban infrastructure systems. So manufacturing, the estimate is around $3.3 trillion, and then for healthcare, 1/6 of the total IoT value is from the healthcare side, and like remote monitoring, diagnostic, asset management, all these things actually IoT supports all these things. And the value creation is in improved performance because we are doing real-time monitoring and control, reduced operational and maintenance cost, because we can predict when failures are going to happen, and we can do minor replacements to reduce larger problems. And then creation of innovative data-driven services. So new services are being designed every day, which is adding value. Of course, I can generate more revenue out of that. And then generation of revenue via digital platforms as well. So examples of IoT from from day-to-day life as well as in urban domain. For example, smart landscaping and urban farming. We see a lot of landscape areas in urban areas. Some people are also now going for farming practices in urban areas as well. So we can use sensors to monitor the soil health, like how much water is there, humidity is there. We can monitor the plants, we can monitor the microclimate, and accordingly we can change certain kinds of, the amount of water that has to be given in, the amount of nutrients that has to be given in. So it's a continuous data on environmental systems are being procured, and we can also act upon it, right? So we can do data-driven irrigation and plant care, based on that. That means spraying of certain kinds of pesticides, and all these things could be more controlled or monitored. So this improves maintenance, improves productivity, it improves resource efficiency, as well as this allows us to do precision agriculture. So that's a very, very key term in today's context, where we can actually prevent a lot of loss in agriculture by doing this kind of smart systems. Then, for example, we detect some kind of insects in the field, right, based on some sensors, and immediately I can start spraying the insecticides and other things, right? So those kind of things can happen. Sometimes the information comes that, okay, we have observed some of those insects in some nearby fields, right? But that takes time. But if I can immediately monitor and I can immediately intervene, that will save time, and I will probably be able to save the crops, right? Then it could be for security applications. Again, a lot of implications in urban areas. We have sensors, we have cameras, which may be connected to like something called this Raspberry Pi system, right? Pi-based system. Now, it's basically a smart board computer. It's a single board computer. It's a device where we can both attach sensors as well as we can do a lot of processing inside, right? So it is also wirelessly connected, and we can do image processing analytics within that. Most microcontrollers do not have that much amount of memory capacity and all. So we cannot do very complicated calculations. We can do basic stuff, and then we can also take some actions, right? But Raspberry Pi will allow us to not only do that, it will allow us to do Python coding and and embedded Python and all these things, embedded C coding, and then it will allow us to generate programs, AI programs, so that we can do more robust analytics at the location itself. So we can process the image, we can process we can do the analytics on that, and then we can create alerts via mail, mobile web app, dashboard. So it could be done from this particular device. So this will improve surveillance, it will help us to improve detection, it will help us to generate real-time alerts, and so on. So then, of course, we see other uses like home automation. That means we can do centralized control via smartphone or tablet, and how the smartphone or tablets connect to the device actuators, which will move on the blinds or the curtains or turn on the light. So that is actuation. That is, I'm doing something, right? So that means first I have to send the information from my tablet and mobile phone to my microcontroller, or rather the mobile phone is, or that your tablet is the microcontroller, acting as the microcontroller, and it can communicate information to that particular device, which will be able to do something. So some amount of the device itself, it will be receiving an instruction from this particular smartphone or tablet. So that itself becomes the receiving end. From the receiving side to actual doing side, that is the actuation side, this together is the IoT system. So we can control lighting, speakers, appliances, security, via home automation, environmental control, like we can change the value of the thermostat. So when I come to my room, it will be already chilled. Or we can look into safety systems, install safety systems such as smoke alarm, surveillance systems, energy monitoring. All these things could be done via IoT systems. And okay, we can do shopping process automation. So this is will be of interest to the business people, or the real estate, the mall estate, people. So that is the businesses which run malls and the real estate associated with malls and so on. So we can use RFID tags there it could detect that a customer is entering. The products can communicate availability and information. That means the product, when it is taken away, we automatically, the database gets updated. We can know which product has to be bought or which products is being sold, and so on. Then accordingly inventory gets updated automatically, and payment is automated via smart card. So we are creating value by automating. That means we will reduce the number of people employed in that mall. We can reduce the amount of time entering data or doing those sort of basic analysis. And this also gives seamless shopping experience to the people, because they will never find something running out of the stores. And real-time inventory management actually helps in doing that. And then there is, of course, reduced human intervention. Then looking into transportation system, you can see over here, that means IoT systems could be installed in vehicles, within vehicle fleets, or with the drivers, with the mobile phones themselves. That could be the IoT device. And so onboard devices collect real-time data, and this data could be like the GPS data, the location, latitude, longitude data, which could be collected by a GPS chip, a GPS, you can say a sensor. Vehicle performance matrix, that means how the vehicle is performing, that information could be collected from the vehicle OBD ports or from a vehicle information system. The driver behavior could be detected based on the patterns of his driving, when he's stopping, when he's accelerating, and so on, and the hours and distance traveled. All this basic information could be procured. So data transmission definitely happens via the cellular and satellite networks. Processing happens in the cloud or in the data centers, and finally information is delivered to web and mobile dashboards, and analytics and reports could be done, and reports can be generated. So you see over here, we are eventually it's going to decision support. That means we are continuously sensing, and eventually after processing all this data and all, we are giving decisions or support to decisions. So IoT is actually not a gadget. IoT is more like a pipeline or a service. So you can see the images over here, which actually illustrates how the you can say how the signal travel or how the data travel over the different stages of from data acquisition to data transmission to data processing, and then finally showing the information for which will add value. So two more concepts we will discuss because increasingly we are seeing that IoT this entire thing is a little bit we are now changing the way we are looking into IoT. So sensing as a service, particularly for smart cities, is becoming very important. So that means we have a distributed network of sensors and of course IoT systems to transmit the data and to a cloud platform or so on, like smart waste bins, different forms of infrastructure, vehicles, and so on. And this data collection data could be collected via fixed gateways. That means hard connections via the internet from those particular IoT systems, or it could be via mobile through Bluetooth connecting first with the mobile and the mobile sensor data, or through Wi-Fi and so on. And then cloud platforms can offer this sensing as a service. That means the sensors that are being put is independent of the actual use of the data. So that means a company puts up all the different kind of sensors and makes the data available for whoever wants to buy the data. And there could be different stakeholders who would consume the same data, so they will pay charges for it. Like in case of Google, if you want to use Google's navigation and this kind of routing and other kinds of information, and you do it at a larger scale, that means not an individual scale, because Google gives you a free limit to how much you can use. But if you exceed that limit, you have developed your own app which is continuously accessing Google's data, right, using API keys and all. So obviously, you have to buy that data. So you have to pay for that money, right? So that is also very, very important. So sensing is becoming as a service, right? Most companies are collecting data and they are now selling or monetizing it as well. So in this case, stakeholders in urban areas could be city councils, utility companies, manufacturing companies, health and safety agencies, and so on, and they can all use the data which is there across in the city, offered as a sensing as a service, and they can make meaningful decisions using that data. Then there is another dimension that is happening is wearable computing. That means it is now we are moving into a phase, not only we are wearing some device, but there could be direct interface with the brain as well. So research is going on in those direction as well. So we can do very basic stuff like EEG based wearable headset, or it could be a direct neural link, as in case we already know that those researches are going on. And it allows interaction with computers using brain signals and extended, and this could be also not only the brain sending of signal, but some actuation can also happen after that, and sometimes it could be also extended to health and fitness monitoring in general. So we are able to capture the physiological signals such as brain waves, heart rate, and all this actually help us to take the decisions. And these are now getting embedded in many wearables in these days, and this allows large scale capture of personal data and wellness data, which can improve the quality of lives of people as well. So there are also other issues of ethical issues, privacy issues, data ownership issues in IoT, which also needs to be understood when we are talking about IoT applications. So these are some of the references that you can study. To conclude, IoT transforms cities from reactive systems into proactive, sensor-rich and data-driven environments by tightly integrating sensing, communication, analytics and actuation for informed planning and governance. Thank you.